Video, I'm going to show you how to do Edexcel A-Level Maths Paper 1 from June 2023, question 14. My name is Sunil Tanna. I'm a tutor and author. I live in Buckinghamshire, England. I'm available for one-to-one tuition both in person and online. Please like and subscribe. Question 14. Prove using algebra n plus 1 cubed minus n cubed is odd for all n where n is a member of the natural numbers. Okay. There's a lot of ways to do this, but the simplest way is to consider the options if either n is even, either odd or even. So let's have a look. First of all, if n is even. If n is even, we can say let n is equal to, say, 2k. So that tells you n plus 1 cubed minus n cubed is equal to 2k plus 1 cubed minus 2k cubed. Now you could obviously expand that out by hand, but we can use binomial expansion to save ourselves a little bit of time. So it will be 3c0, 3c1, 3c2, 3c3. If we do it decreasing powers of k, 2 cubed, 2k cubed, 2k squared, 2k to the 1, 2k to the 0, and then increasing powers of the other term. So it'll be 1 to the 0, 1 to the 1, 1 squared, 1 cubed. Each of those are added together, and then minus this 1 squared cubed, minus 2k cubed, which is minus 8k cubed. So now we can work this out. This will be 1 times 8k cubed, so 8k cubed. This will be 3 times 4k squared, so plus 12k squared. This will be 3 times 2k, so plus 6k. This will be 1 times 1 times 1, so plus 1 minus 8k cubed. And you can see that this simplifies now. The 8k cubes cancel out, which is 12k squared plus 6k plus 1, which is the same as 1 more than an even number. If we factorise out the first two, you could obviously factorise out any even factor. I'll factorise out 2 to just show it's a multiple of 2. So 2 times 6k squared plus 3k, so it's, and then plus 1 for that plus 1 here, which is an even number plus 1, so this is definitely odd. Likewise, if n is odd, we can consider that case. If n is odd, let n is equal to 2k plus 1. So in this case, n plus 1 cubed minus n cubed is 2k plus 1 plus 1, so 2k plus 2 cubed minus 2k plus 1 cubed. Well, we've also worked out what 2k plus 1 here is in this, using this binomial expansion. So we'll be able to subtract that. So let's do that here. So the first part here is going to be 3c0, 3c1, 3c2, 3c3, and then again we'll do decreasing powers of k, so 2k cubed, 2k squared, 2k to the 1, 2k to the 0. This time it'll be increasing powers of 2, so 2 to the 0, 2 to the 1, 2 squared, 2 cubed, and we can use what we worked out before for the second part of the expansion, so minus here, and then in brackets, 8k cubed plus 12k squared plus 6k plus 1. Now if we simplify this, the first part here is going to be 1 times 8k cubed times 2, so 16k cubed. Then it will be 3 times 4k squared, no, so it won't, so it's 1 times 8k cubed times 1, so that's 8k cubed. Then it will be 3 times 4k squared, so 12k squared times 2, which is 24k squared. Then we have 3 times 2k, which, so 3 times 2 is 6k, and then times 4 is 24k. And then we have 1 times 8, so plus 8 here. Then we're going to have minus 8k cubed, minus 12k squared, minus 6k minus 1 once we remove those brackets. this now simplifies. 8k cubes cancel out. 24k squared minus 12k squared is 12k squared. 24k minus 6k is 18k. Plus 8 minus 1 is plus 7. Now again here we can see that there's going to be an even number plus an odd. The easiest way to show that is show this has a factor of 2 or any even factor. So here it will be 2 times 6k squared plus 9k plus 7, which is an even number plus 1 plus 7. So therefore this is also odd. Yeah. So if n is even or odd, the result is always odd. And that completes the proof.